let's see how we are going to resolve this question. Now, looking at this question, you see that before you can tackle the cos inverse, you have to deal with this first. So, having this question is you applying your what? Your chain what? Rule. And the inverse trig will review itself. So now, this is going to be something like dy ds is going to be equal to differentiate this. So when you differentiate cos, you get negative cosec square. Cosec square of what? The argument. So you will bring the argument, which is cos inverse of what? S square. Alright. Then you do what? You differentiate the inside. So the derivative of the what? Of the inside. How do you remember chain of trig functions? Okay, so this is what we are going to have. So now, we just need this so that we can proceed. So, with this, we are going to get, we know that the derivative of, cos inverse of s squared is going to be 1 over the square root of this cos inverse, right? That is u squared minus 1. And we know the u is what? S squared. So that's going to be s raised to the power 4 minus 1 times the derivative of this. And the derivative of this is what? 2s. 2s. So therefore we are going to get 2s, all this over square root of s to the power 4 minus 1. So now we are going to do substitution. So therefore dy ds is going to be equal to negative cosec square cos inverse of s squared times the derivative of this, and that is that 2s over square root of s squared minus what? S to the power 4 minus what? 1. Alright. So now, having this question, you are done. Yeah, you are done. But you can still reduce it. And if you want to reduce what we have here, then you have to apply your idea of how to evaluate what? Trig functions. So, let's see how we are going to do it. You see that having this question, having this, let's write only this side. We can let theta to be equal to what? Cos inverse of what? S squared. So we can say that cos theta will be equal to what? S squared by multiplying both sides by what? Cos. We are going to get this. And this is the same as over what? 1. And we can present this on a right angle triangle. So the angle is what? Theta. Right? So that means that our hypotenuse will be here because this adjacent over what? Hypotenuse. So the adjacent is this. So how can we get this side? How can we get this side? So that's going to be square root of 1 minus what? S squared. You can try and see, set here to be y. So take y squared, this square, equal to this square, and you're going to get this. You know how to do that by Pythagorean theorem. Alright. So now after getting this, then once you have this, then we can establish this. We can establish that. Because now we are going to leverage, here is going to leverage negative cosec square theta, because everything here is theta. So now, what is cosec square theta? We know that cosec square theta is going to be, cosec is a reciprocal of what? Sine. So if sine is, that is so opposite over hypotenuse, opposite over what? The hypotenuse. Then cosec is going to be what? hypotenuse over what? Their opposite. So this is going to be equal to negative 1 over square root of, don't forget, I'll bring this one, square root of 1 minus 1 s squared. Alright, so now what we have here is, you don't worry, cos theta. This is cos theta. So to get negative cosec squared theta, we are going to do it this way. Bring the negative, repeat the cosec. Right? Now this means that we are squaring it. We are squaring this and this. So we are going to get something like negative 1 over, and because of the square here, the root will go 1 minus 1 s squared. So the whole of this that you see here is summarized to this. Beautiful. So now we can get, we know that everything here is this. So now dy ds is going to be negative 1 over 1 minus s squared times 2s over s to the power 4 minus 1. I hope you can see that. Alright. Alright. Oh, sorry. Here is going to be power 4. Here. Oh, sorry. Here is going to be power 4. Here will be power 4. Here will be power 4. Thank you. So now, with this, here is going to be power 4. So this one is going to be equal to this times this. You get negative 2s. Right? The whole of this over this times this. The inside is the same thing, right? So this is the same as power what? 1. Is that also? And this half. So 1 plus half, you are going to get what? 3 over 2. So with this, you can get 1 minus s to the power 4. 3 over what? 2. So I think that's it. That's how it's going to be. And then, yeah. So see you for another video. Or let me add one question to it. Okay, let me add one question to it. Let's look at let's try one question at a time. Let's say s squared tan inverse of 2x. Tan inverse of 3s squared plus 1. Let's try a question like this. Yeah, with the time left, we can do that. Or I will pause the video there, you continue. So now looking at this. This is what? A product what? Rule. Because you can see it here. But product rule. So you define your f of x to be equal to s squared. F prime of x will be equal to 2x. You know already. And g of x will be equal to the tan inverse of what? 3s squared plus 1. So you go for g prime of what? X. So how do we take g prime of, now this one is for tan inverse. And you know that tan inverse, the formula is square root of 1 minus 1 plus u squared. And the u is this. So 3s squared plus 1 all squared times the derivative of this. So when you differentiate this, okay, let's continue. When you differentiate this, you are going to get g prime of x to be equal to 1 over square root of 1 plus 3x squared plus 1 all squared times the derivative of that, which is 6x. Alright, so this is going to be 6x over 3x squared plus 1. So that's what we are going to have. So now that you have your f prime and g prime, we can take our derivative. So dy dx is going to be, so product rule, leave the first one, differentiate the second, and that is this. Alright? Plus, now, differentiate the second one, which is 2x, and leave the first one, which is tan inverse of 3x squared plus 1. Alright, so with this, we are going to get 6x to the power 3, all these over 3x squared plus 1 plus 1. Plus, this and this, you get 2x tan inverse of 3x squared plus 1. So that's going to be our final answer for that. Thank you. See you.